Okay, let's see if we can go through these practice questions for the radicals practice test. First one says simplify the radical expression. Well, we know we can rewrite this as square root of 72 can be rewritten in a number of ways. I can see real quick that we could just say the square root of 36 times the square root of 2, because I'm looking for perfect squares. The largest perfect square I could find, and that's, of course, 36. So the square root of 36 is 6. We can't do anything with the square root of 2, so it's 6 times the square root of 2, so it's answer C. That's the first one. Okay, the next one, simplify the radical expression. The square root of 79, square root of 49, a to the 8th. Well, we can rewrite this. We can just say square root of 49 times the square root of a to the 8th. I'm starting it that way because hopefully we recognize that the square root of 49 is 7. So then we have this left. So what do we do with this? Well, that can be rewritten as square root of a squared times the square root of a squared times the square root of a squared times the square root of a squared. Well, and I did it this way because we know that anything, the square root of anything squared is itself. So that gives me a times a times a times a. Right? So a times a times a times a is simply a to the 4th. It gives me 7a to the 4th, which is C. Okay, number 3. Let's see. Simplify the radical expression. 2 times the square root of 10 times 3 times the square root of 12. Well, let's rewrite it. 2 times the square root of 10. I can't really do much with the square root of 10 because I could break it down to 5 times 2, but neither one of those are perfect squares. Times 3 times the square root of 12. Now the square root of 12 can be rewritten as 4 times square root of 3. I did that because 4 is a perfect square. So that gives me 2. Of course, I have to multiply that times 3. It gives me 6 times square root of 3. But I also have to remember I've got this other part over here that I have to bring down, which is 2 times square root of 10 times 6 times the square root of 3. So, I'm going to change colors here just for a second. I didn't change colors. Let's try that again. Let's just do something like that. So 2 times 6 is 12, and 10 times 3 is 30. So that matches right here. 12 times the square root of 30. So that's your answer for number 3. Okay, number 4. Simplify the radical expression. Forget about this part. That's from the next question. So just get that out of the way so you don't get confused. So we've got this right here. So we can rewrite that as the square root of 80 w cubed over the square root of 9. The reason I did that to start is because I recognize that the square root of 9 is a perfect square, and that's 3. So to get this started, now we have square root of 80 w cubed over, well, square root of 9 is 3. So that's where we're starting. So now we need to figure out what we're going to do with this 80. Okay, so I might not immediately recognize where my perfect square, my largest perfect square is, which I'll put in blue over here, because I know it's 16 times 5 is 80. 16 is a perfect square. So I might have to think about this 80 for a minute and go, okay, well, what else can it be? It can be 40 times 2. No perfect squares there, but this could be 20 times 2 times 2. Well, there's a perfect square, which is 4. This 10, there's 20 also could be 10 or 5 times 4 times 4. And there's my 16, which is a perfect square. So I'd have square root of 16 times 5. I haven't worried about this w yet. I'll get to that in just a second. So right now I've narrowed this down to the square root of 16 times the square root of 5. And I've got to remember this square root of w cubed. But I have reduced the denominator to 3. So now what can I do? Well, the square root of 16 is 4. Right? So we got 4 times square root of 5 times square root of w cubed over 3. And again, this w cubed, I'm going to bring that all the way up here. Way up here. Square root of w cubed. Well, that can be rewritten as the square root of w squared times the square root of w. The reason I did that is because we know anything, square root of anything squared is itself, is w. So that leaves me with w times square root of w. So I can keep that in mind just for a second. W times square root of w. Right? So now what do I have left? I've got right here, right? 4 times square root of 5 times square root of w cubed. So I'm left with 4. I brought this right here, this w out, but I also had this. I've got 4w times the square root of what I was left with. Let me change colors again. What I was left with here, which is square root of 5, still under the radical sign, and this w, which is still left under the radical sign. So that goes down here. So I've got 4w times square root of 5w all over 3. So let's see. That must be B.